rotation. We did a little bit of rotation. Today we'll do properties of solids. We'll see certain properties of solids, and then we'll start with the properties of fluids and liquids in the next class.
Okay, sir.
Your last class was chemistry class or maths class?
Chemistry.
Chemistry class. So today's topic is properties of solids. So we will see different properties of solids. And first of all, we observe that almost all the solids they exhibit a property of elasticity. So one of the important properties of solids that we will look up is property of elasticity. Elasticity is the property of substances to regain their original shape. So it is the property of substances to regain their original shape. Okay. So what happens when you apply some deforming forces on the solid? So suppose you have a steel rod, and we can observe this in various cases. Suppose you have a steel rod like this, and on this steel rod you hang a weight. So in the center, if you hang a weight in the center, so let's say we hang a weight over here in the center. If we hang the weight in the center, we will observe that the steel rod, it bends in the center. So there will be a bending produced in the steel rod, something like this, and the substance will be hanged from it. It will be something like this. A small bending will be produced in steel rod, or you can take any material. If you hang some amount of weight on, so it will get bent. And once you remove the weight, so it will regain its original shape. It will take some time, but it will regain its original shape. So this property of the solids is called as elasticity. The similar thing happens with the spring also. So if you have a spring, and on the spring, so we take a spring. On the spring, if you hang a mass, so by hanging of some weight on the spring, some extension is produced in the spring. The spring gets extended. If you remove the weight, so the spring comes to its original position. It comes to its original shape and size. Okay. So by this we confirm about elasticity. So elasticity is the property of substances to regain their original shape. Okay. Now we'll try to understand why there is elasticity, why the substances are elastic. We observe certain substances are brittle. If you apply some amount of force, so they get broken up. For example, if you see crystals, so if you try to break the crystal, so those crystals break up. They do not undergo elasticity. Their elasticity is very less. You can say they are very less elastic. Okay. But other substances like metals, they are highly elastic. So they can withstand a very high amount of force. So all these substances, they are elastic. Now why they are elastic? Can you think of any reason why the substances are elastic?
So intermolecular force.
Yeah, it is the intermolecular forces. The intermolecular forces which are holding the molecules together, the one molecule which is attached to the other molecule, it is the intermolecular forces. If you apply some amount of force, so the distance between the molecules increases, and hence they undergo a change of their shape. If you remove the force, if you remove that force, then what will happen? Then the molecules will attract each other, and hence they will regain their original shape. So this is called as elasticity. Now, with elasticity, we have a formula, we have an explanation which we call as the Hooke's law. So as per the Hooke's law, the extension produced in a substance or in an elastic body or in a substance is directly proportional to the restoring force is directly proportional to the restoring force developed in it. So what is the restoring forces? Let us try to understand the restoring forces also, and then we'll see how it happens. So here, suppose we take the case of spring and consider, let the spring originally have some length L. So let this be the original length of the spring L. This is the original length L. Now, if you hang some weight on it, so from here, if you hang some weight, we observe that some extension X is produced in the spring. The extension X which is produced in the spring is directly proportional to the weight or the force which is acting on it. Now, if you hang the weight, so the molecules or the particles, they are brought down, they extend. So the spring extends down, but as they extend, the molecules, they try to pull it up. The molecules of this spring, they try to pull the spring up. So at a stage where the force of gravity or this weight of the substance, where the weight is equal to the restoring force set up in the spring, since the molecules are also trying to pull it up. So when the weight is equal to the restoring forces, so that is the time when they are balanced, and hence at this situation we will say that the restoring force is equal to the weight, and we can apply the Hooke's law. By the Hooke's law, it states that the restoring force is proportional to the extension. Here extension is denoted by the symbol X. But another point to be noted here, that the restoring force, if you observe the restoring force, it is set up in the upward direction. Right? But the extension which is produced in the spring, that extension is produced in the downward direction. So since the two, that is force and extension, are opposite to each other, so therefore we can write here force proportional to negative of x. Why a negative sign? It is because the restoring force is opposite to the direction of extension. Okay. So the restoring force F is directly proportional to negative of x. If we remove the proportionality, we get F equal negative kx. Here the k which is there is called force constant or spring constant. It is either called force constant or spring constant. So what should be the units of this force constant or spring constant?
Newton meter.
Yes,
Yes, Newton meter.
Newton meter. The units of this K would be Newton meter. We will call this K, we will measure this K in Newton per meter. It is Newton per meter. Okay. So let us try to solve one question here. We have a mass of 100 gram is hanged from a spring to produce an extension of 6 centimeter. So you have to find the spring constant. Find the spring constant. Then second thing, you also have to find the extension produced when a mass of 120 gram is suspended from it. So just one, can you do the first part?
Yes, sir.
Hmm?
Yes, sir. 100.
So what is the answer for the first part? You have to find the force constant. So you need to use the formula F equals minus kx. Okay. So since we just have to put x as negative, or we can take f as negative, so we can omit this minus sign here. Force will be equal to the weight. So we know that the gravitational force is equal to the weight, which is given by the formula mg. So m should be taken in kilogram, which is 0.1 multiplied with g, that's 9.8. So 0.1 multiply 9.8 is equals to minus of k times x, which is 0.06 in meter. So the extension produced here, extension is 6 centimeter, which we write as 0.6. X equals 0.06 meter. Now putting these values here, you get 0.1 multiply 9.8 divided by 0.06. So you get your K. So you can take this 9.8 to be approximately 10. Or if you multiply it like this, you will be getting 98 over 6. That should be the value of K. Got it? So you can divide this. You will get the answer. Dividing 98 by 6,
60.
you get 16.3 Newton per meter. Now, for the second part, you have to find the extension. Okay. So, Jaswant, can you get the answer for the second part?
Yes, sir. Yes, sir.
Okay, so did you have you got the answer for the second part? Use the same one. F equals kx.
Calculate.
Are you traveling somewhere, just one?
Yes, sir, I'm doing.
Okay. So force would be 0.12 multiply G, that's 9.8 equals K, which is 98 over 6, and multiply X. So you should be getting here 0.12 multiply 9.8 multiply 6 over 98 should be equals to X. So remove this point, get a 10 at the denominator. 98 cancels, and you have 0.72 meter. So that's 7.2 centimeter. It's 0.072. That 7.2 centimeter is the extension produced. So, so this was about the Hooke's law. We can find out the extension and the spring constants due to which the extension is produced. So let's do another one. Just one.
Yeah, okay, sir. Yes, sir.
Okay. So let's try to do the next one. So a spring with spring constant. A spring with spring constant K equals 120 Newton per meter is used for making a spring balance. So if maximum allowed extension is 15 centimeter, find the maximum mass that can be hanged from it. So just do this part now. We have been given the spring constant. You have been given the maximum extension that has been produced. So see here, we write
18.
again F equals Kx. We obtain the value of F. So F should be equal to mg. For simplicity, just let's take the value of g to be 10. So we write mg equals k times, that's 1200 multiply 15 centimeter is 0.15. So mass that can be hanged will be equal to 1200 multiply 0.15 over 10. So you have 12 multiply 15 by 10. Can cancel it. Have 6. You have 18 kilogram. So the maximum mass that can be measured through this spring balance is 18 kilogram, right? So these were some properties which were based on elasticity. There is another property which is based on elasticity. So we'll also observe what can you say about a rubber band? Is rubber band more elastic or steel more elastic?
Yeah, rubber band. Rubber band.
Rubber band?
Yes.
Yes. So generally, we think that rubber band will be more elastic, but we observe that rubber band is not more elastic. It is the steel that is more elastic than rubber band. So why it is? The elasticity is measured on the basis of so the elasticity of the steel. Steel is more elastic. So on what basis we can measure? We measure it how much of the load can be suspended from it. Which out of the two can have the maximum load suspended on it?
Steel.
Steel. Okay. So if you suppose you take a rubber band and you take a steel and you suspend 1 kilogram on both of them, so steel will produce a smaller amount of extension, whereas rubber band will break up. So we'll say that here steel is more elastic. Steel can withstand a higher stress. It can withstand a higher stress. So steel is more elastic than rubber band. Then in the similar way, we also have some properties. Another term is we have terminal velocity. So this is a very important concept of terminal velocity. Terminal velocity, it is the maximum velocity it is the maximum velocity attained by an object moving through a liquid or fluid okay. So see, even if there is a constant force acting on it, then also the substance attains a terminal velocity. Let us try to understand what we are talking of the terminal velocity. As we know that air offers resistance, right? We know that air offers resistance to all the objects moving through them, and air is a type of fluid. So as suppose I take a ball which falls through air. So this ball falls through air. As this ball falls through air, its velocity increases. We know that its velocity will increase due to acceleration due to gravity. Here we have acceleration due to gravity acting in the downward direction. We have velocity also acting in the downward direction. So because of the velocity and acceleration acting both in the downward direction, and the ball is accelerating downward. Okay? Its speed is increasing in the downward direction. Now, its velocity will increase too much, but we have air in between. The layers of air which are present, they do not allow the ball to move through them. So we have, suppose you have these layers of air which through which the ball has to move. Now when the ball moves through these layers of air, so these layers, they offer resistance to the ball, and hence they offer a backward force. So this ball is offered a backward force which we call as the drag. So there is a backward force offered to this ball, and this backward force is dependent on the speed of the ball. Faster the ball, it depends on the speed of the ball, it depends on the shape of the ball. So if the ball moves faster through air, if its speed increases, the drag force increases. So the drag force increases if there is, if the speed of the ball increases, right? So here, as more and more it will gain its speed. See, suppose at this point it attains a certain speed such that at this point its downward force and the drag, its gravitational pull acting downward, and the drag that acts upward. So the two forces you have your weight, that is a gravitational force. In the upward direction, you have the drag. So if both the forces equal each other, then no net force will act on the ball. As a result, the ball will not accelerate. There will be no acceleration, and hence the ball will continue to move downward with the same velocity. Its velocity will not increase further. Since we observe here that the velocity of the ball does not increase further in this case, so we will say that the ball has attained a terminal velocity. Okay. So just one, what is terminal velocity? Can you explain?
So the maximum velocity attained when an object is moving in fluid.
Yeah. So the maximum velocity attained by an object moving through a fluid. And that is also the reason if you move your vehicle with high speed. So your vehicle will experience greater drag. So the vehicle will experience a greater drag, that is because of its speed. Since the drag force is directly proportional to the speed, so therefore its backward force or its drag force will increase, and hence if you drive a vehicle fast, so it will be experiencing more drag, and hence more fuel will be consumed by it. So hence, uh, in this case, we obtain here terminal velocity. That means if the ball or any object falls down, so a point comes when the drag force and the weight, they are equal, they balance each other. Hence, no net force act on it. So therefore, its backward dragging force is equal, and hence acceleration is zero. So therefore, it moves with a constant velocity called as the terminal velocity. So it happens when a substance moves through a fluid. Now, the same case, the same thing, if we apply to falling raindrops, we have falling raindrops here. So whatever raindrops are falling, we can consider them to be the same way. The raindrops, they fall down due to the gravitational pull. And as they fall down, their speed increases, and hence the backward dragging force also increases. Right? So therefore, they attain a terminal velocity, and beyond that, their speed does not increase. Okay. Now here, if for these objects, for these drops, if there was no backward dragging force, if there was no air, no backward dragging force, so these drops would hit the ground with very high speeds of nearly 200 to 300 meter per second. So the speed of the ball would have been very high if there was no dragging force. There was no drag. Okay, just one. So today we have discussed about the spring constant. We have discussed about the elastic behavior of the materials, why certain substances are elastic, why some substances are non-elastic. It is just the bonding between the molecules which makes them elastic. Okay. So we will also see different types of elasticity. Another term here is elastic limit. See, I give you another term, elastic limit. So it's not that if a substance is elastic, you can put any amount of stress on it. Okay. There is a limit to it. So that maximum you have maximum force or maximum stress up to which the substance has the capacity to regain its original shape. This we call as the elastic limit. Okay, just once. Bye. We'll see you again tomorrow.